At 3:44 in the morning, the first live haul truck of the day clears the security gate at a Tyson Foods processing complex in northwest Arkansas. The driver has been on the road since 1:09 a.m. The truck carries 7,200 broiler chickens. Each bird weighs 6.3 pounds. They came from a contract grower farm 34 miles east, loaded in darkness by a catching crew that worked the house in under 90 minutes. The birds are calm. Darkness does that. The catching crew knows this. Every poultry operation in Arkansas knows this. It is why the trucks run before sunrise and why the loading crews start at midnight and why the entire live haul logistics system of the American broiler industry is built around the biological fact that a chicken in darkness is a manageable chicken. At the receiving dock, the clock starts. Tyson Foods processes approximately 1 million chickens every single day across its Arkansas operations. 1 million. Every 24 hours. The scale doesn't register until you do the math. That's 41,667 birds per hour. 694 per minute. Nearly 12 per second, every second, around the clock, across multiple shifts, across multiple plants, across the same Ozark Plateau where John Tyson sold chickens from the back of a truck in 1935. 90 years later, his company is the largest chicken producer in the United States. And it starts with a truck at 3:44 in the morning. Northwest Arkansas is not where most people expect to find the center of American industrial poultry. No coastline. No port access. No obvious geographic advantage visible from a map. The advantage is invisible. It lives in the soil. The Ozark Plateau's thin rocky terrain, unsuitable for row crops, pushed early settlers toward livestock. Chickens needed less land than cattle. Less water than hogs. A family with 5 acres and a small barn could raise a flock. They didn't need irrigation systems or heavy equipment or the flat bottomland that corn and soybeans require. They needed space, shelter, and feed, and the railroad that arrived in Springdale in the 1880s brought feed from the grain belt at prices that made small-scale poultry commercially viable for the first time in the hill country. By the 1920s, northwest Arkansas had something rare, a critical mass of small farms already raising chickens for local markets, a rural labor pool experienced in livestock handling, and a transportation infrastructure capable of moving perishable product to distant cities. Fort Smith to the south. Kansas City to the north. St. Louis to the east. The region sat within overnight rail distance of 3 major urban markets before the interstate highway system existed. John Tyson arrived in this geography in 1931, moving from Missouri to Springdale during the Depression. He was not a farmer. He was a hauler. He saw that northwest Arkansas produced chickens and that Chicago and Kansas City wanted to buy them, and he built his early business on the gap between those two facts. By 1935 he was transporting live chickens north in trucks outfitted with feed and water systems that kept the birds alive through multi-day journeys, a logistics innovation so specific to his moment that it defined what came after. He didn't invent contract growing. He perfected the economics of it. The contract structure that Tyson refined through the 1940s and 1950s, the company providing chicks, feed, veterinary services, and a guaranteed purchase price while the grower provided land, labor, housing, and utilities, solved the capital problem that had prevented vertical integration in poultry until that point. A single company couldn't own enough land to raise the volume of birds that profitable processing required. But it could contract with hundreds of families who already owned the land, had the labor, and needed only the capital commitment that a guaranteed market represented. That structure, refined across 8 decades, now coordinates thousands of contract growers across Arkansas, Missouri, Oklahoma, and beyond. Each grower raising Tyson's birds. Each flock destined for one of Tyson's Arkansas processing complexes. The relationship between the company and the grower has evolved through legislation, litigation, and renegotiation across a century, but the fundamental structure John Tyson established in the 1940s remains the operational core of the largest chicken company on earth. The birds on the 344 truck came from one of those growers. The contract grower whose farm supplied the 344 truck operates 4 grow-out houses in Madison County. Each house is 60 feet wide and 500 feet long. Each holds approximately 30,000 birds. Combined capacity, 120,000 birds per flock cycle. The birds that loaded onto the 344 truck arrived at this farm 42 days ago as day-old chicks, yellow, fragile, weighing 45 grams each, delivered in ventilated cardboard boxes on a Tyson delivery truck before sunrise on a Tuesday morning. The grower had prepared for their arrival for 3 days, cleaning and disinfecting the houses after the previous flock's removal, adjusting the brooder heaters to 90 degrees Fahrenheit across the floor, charging the feeders, flushing the water lines, spreading fresh litter, pine shavings, 4 inches deep, across every square foot of house floor. When the chicks arrived, the brooding temperature was exactly right. The feeders were full. The water founts had colored marbles in them, a detail that seems trivial until you understand that day-old chicks are attracted to shiny objects and that the marbles teach them to find the water source before they die of dehydration in the first 48 hours. The catching crew that loaded the 344 truck did not load chicks. They loaded 6.3-pound market-weight broilers, birds that consumed 18 pounds of Tyson-formulated feed over 42 days and converted it into meat at a feed conversion ratio of approximately 1.85 pounds of feed per pound of live weight gain. 18 pounds of feed. 42 days. 6.3 pounds of market-weight bird. That feed conversion ratio, 1.85, represents decades of genetic selection and nutritional science. The commercial Cobb 500 or Ross 308 broiler that Tyson raises today grows twice as fast on half the feed of the broiler chickens raised in 1960. The breast muscle that comprises the most commercially valuable portion of the bird has been selected to grow at a rate that would be biologically impossible in any wild bird. The modern broiler reaches market weight in 42 days. Its wild ancestor required years. Tyson's genetics program, the breeder flocks and hatcheries that produce the commercial chicks delivered to contract farms, is the invisible upstream infrastructure whose output determines everything that happens downstream. A 1-gram improvement in average hatch weight. A 0.01 improvement in feed conversion ratio. A 1% improvement in livability across the contract farm network. At 1 million birds per day, each of these improvements compounds into financial outcomes that justify the genetic research investment many times over. The hatchery that produced the chicks on the 344 truck operates in Benton County, 41 miles west of the Madison County farm. The hatchery's role in the vertical integration chain is to convert fertile eggs from Tyson's breeder flocks into the day-old chicks that the contract farm network requires, on a schedule precise enough that every contract farm receives its placement within the 48-hour window that the bird's biological needs and the farm's operational calendar allow. Fertile eggs arrive at the hatchery from Tyson's breeder farms within 24 hours of laying. They enter setter incubators where temperature is held at 99.5 degrees Fahrenheit with precisely controlled humidity and programmed turning. The egg rotates on a schedule that mimics the natural turning a brooding hen performs, for 18 days. On day 18, the eggs transfer to hatcher cabinets where temperature drops slightly and humidity rises for the final 3 days before hatch. Day 21. The chick pips through the shell. From pip to box to truck to farm takes less than 36 hours. A chick that hatches Tuesday morning is on a contract farm in Madison County by Wednesday afternoon. The window between hatch and first feed and water access determines first week livability. The biological clock that the entire downstream production system depends on starts the moment the chick emerges. The Benton County hatchery sets millions of eggs per week. The number required to support 1 million daily processed birds at 42-day grow-out cycles and typical livability rates demands a hatchery infrastructure operating at scales that make the facility itself one of the largest biological production systems in the state. The feed mill that supplied the Madison County farm operates in Washington County, 28 miles from the grower's property. Tyson's feed mills in northwest Arkansas produce rations calibrated to the grow-out phase of the specific flock they serve. Starter rations, high protein, fine particle size, energy dense, for the first 10 days when the chick's metabolic rate is highest relative to its body weight. Grower rations for days 11 through 28 as the bird's muscle mass accelerates. Finisher rations for the final 2 weeks, balancing continued growth against the energy cost of the bird's increasing weight. Withdrawal rations in the final days before harvest, containing no antibiotic growth promoters with pre-slaughter withdrawal periods, to ensure regulatory compliance at the processing plant. A 30,000 bird house consuming feed across a 42-day cycle requires delivery on a schedule that the farm's bin inventory and the flock's daily consumption rate determine. The logistics system that coordinates feed deliveries to thousands of contract farms across northwest Arkansas, western Missouri, and eastern Oklahoma runs without interruption because a farm that runs out of feed at day 25, with 17 days of grow-out remaining, loses feed conversion performance that no subsequent management can recover. The service technician who visits the Madison County farm weekly is the human connection between Tyson's standardized protocols and the individual conditions of a specific farm. Ventilation settings. Water pressure. Litter moisture. Feeder height adjusted as birds grow. The technician's weekly visit catches the developing problems: the water line pressure drop that began Tuesday, the litter cake building in the northwest corner since the last rain, the small temperature differential between the east and west ends of House 3, before they become performance deductions at settlement. Settlement. The word matters enormously to the contract grower. The tournament settlement system that Tyson uses, and that most integrated broiler companies use, pays each grower based on their performance relative to other growers in the same settlement group, a cohort of growers whose flocks placed within the same period and processed on the same kill dates. A grower whose flock achieves feed conversion and livability above the settlement group average receives a payment above the base rate. A grower whose flock falls below average receives less. For the Madison County grower with 4 houses and a 120,000 bird placement, the difference between landing in the top quarter of the settlement group and the bottom quarter can represent tens of thousands of dollars per flock cycle. On a farm whose housing investment runs to $1.8 million across 4 houses and whose margin on any given flock is thin enough that 2 consecutive below-average settlements can trigger a cash flow problem. The tournament structure transfers performance variability risk to the grower while incentivizing maximum management effort. Tyson bears the market risk, the commodity price movements and the feed ingredient cost fluctuations that the grower has no ability to influence. The grower bears the management risk, the ventilation decision, the litter management, the mortality response, that the grower can influence and that the settlement formula measures precisely. At 3:44 in the morning, the Madison County grower's settlement calculation for this flock is already partly determined by decisions made 42 days ago and every day in between. Inside the Tyson complex, the kill floor runs before sunrise. USDA inspectors arrive before the first bird does. Federal law requires it. Not periodic audits. Not random sampling. Continuous human presence at every critical point in the harvest sequence from the moment the first shackle closes to the moment the last carcass exits the chill system. The USDA FSIS inspector who walks onto the kill floor at 4:30 a.m. will still be there at the shift change. Another inspector will replace them. The regulatory presence does not pause. At 694 birds per minute, the line never pauses for uncertainty. The live haul trucks that arrive at the receiving dock unload into lairage pens where the birds rest for a minimum of 2 hours before entering the processing sequence. The rest period addresses the transport stress that elevates cortisol levels and depletes glycogen reserves in birds subjected to rough handling, extreme temperatures, or excessively long transit times. A bird that enters the kill floor in peak transport stress is a bird whose muscle will show the pale, soft, exudative quality, PSE, that degrades the product's water-holding capacity, texture, and shelf life. The rest period is not regulatory formality. It is a product quality investment that costs 2 hours of holding space and returns measurable yield improvement. The stunning system renders each bird insensible in under 4 seconds. Electrical stunning at calibrated voltage, the voltage specification matched to bird size and the water conductivity of the bath, calibrated to produce deep unconsciousness without the wing fractures and hemorrhages that overvoltage produces and that downgrade product. The bird enters the water bath stunner in the shackle, exits insensible, and the bleed cut follows within 8 seconds. Exsanguination complete before the bird reaches the scalder. Stun effectiveness verification, the regulatory requirement that confirms each bird is insensible before bleeding, runs as a continuous observation process during the shift. A stunning failure rate that trends above baseline triggers an immediate equipment check. The calibration that worked on Monday morning may underperform on Thursday afternoon if line speed has changed, bird size has shifted, or water temperature and conductivity have drifted outside specification. The scalder runs at 140 degrees Fahrenheit. 60 seconds of immersion loosens feathers across the entire surface of the carcass, the primary flight feathers, the body contour feathers, the pin feathers still emerging from follicles in younger birds. The plucker machine that follows operates at 7,000 birds per hour through banks of rubber fingers rotating at high speed, stripping the loosened feathers from the carcass surface in under 3 seconds per bird. The sound of a fully operational plucker room carries through the walls of the building. It is not a subtle machine. The evisceration sequence is where the kill floor's food safety architecture concentrates. After defeathering, the carcass moves through a series of automated and operator-assisted stations that remove the head, feet, and internal organs in an order designed to maintain GI tract integrity. The gastrointestinal tract, from crop to cloaca, carries the highest pathogen load of any material in the processing environment. The bung cut that seals the cloaca before abdominal opening, the crop removal that clears the feed contents of the upper GI, and the viscera pull that removes the intestinal tract as a continuous sealed unit are each critical control points whose failure creates contamination events with immediate regulatory consequences. Zero tolerance for visible fecal contamination. Every plant manager in the American poultry industry knows this phrase. USDA's zero tolerance standard means exactly what it says: a carcass with visible fecal contamination does not pass inspection. It stops. The line stops. The contamination event is addressed, the affected carcasses are handled according to the regulatory protocol, and production resumes when the USDA inspector determines the corrective action was adequate. At 694 birds per minute, a line stop costs Tyson approximately $6,940 worth of production capacity per 10-minute pause. The financial incentive to prevent contamination events is inseparable from the regulatory requirement to prevent them, which is why the evisceration equipment calibration, the operator training, and the line speed authorization that the USDA inspection system approves are not independent variables. They are a system whose collective function is to move 694 birds per minute through the evisceration sequence without a containment failure. The USDA inspector at the post-mortem inspection station examines each carcass and its corresponding viscera simultaneously as the line passes. The sequential numbering system that connects each bird's organ set to its carcass on the overhead rail allows the inspector to correlate findings: an abscess in the liver, a lesion on the lung, an abnormal kidney, to the specific carcass that produced them. At line speed, the inspection window runs under 2 seconds per bird. The inspector's trained pattern recognition operates in that window across an 8-hour shift without degradation in detection accuracy. The chill system is where Tyson's scale becomes physically overwhelming. The immersion chiller, a massive stainless steel tank running the length of a city block, holds thousands of carcasses simultaneously in countercurrent ice-water flow at 34 degrees Fahrenheit. Carcasses enter at the warm end and travel against the flow of progressively colder water as they move toward the exit, absorbing cold while the water carries heat away. Residence time, 45 minutes per bird. 45 minutes times 694 birds per minute equals over 31,000 birds chilling at any given moment in a single chiller tank. The mathematics of that heat exchange require a refrigeration system of industrial scale. The compressors running the chill system consume electrical power measured in megawatts. The ice production required to maintain chiller temperature through a 16-hour shift runs to tonnages that require dedicated ice-making infrastructure separate from the processing building's general refrigeration load. The chiller's countercurrent water flow generates a continuous outflow of warm water, the chiller effluent, that the plant's water treatment systems process before discharge. From the chill tank, carcasses enter the grading and cut-up sequence that converts the commodity broiler into the specific product forms the American consumer actually purchases. Whole birds, less than 15% of Tyson's Arkansas retail volume. The American consumer largely stopped buying whole birds in the 1980s as the dual-income household normalized and the time required to break down a whole bird at home became a cost that consumers were unwilling to pay. What replaced the whole bird was parts. And parts became boneless. And boneless became marinated, seasoned, and ready to cook. The evolution of the American chicken purchase from whole bird to parts to further processed convenience products maps almost exactly onto Tyson's product development history across the same period, because Tyson's marketing and product development team was not following consumer preferences. In significant ways, they were creating them. The cut-up lines at a Tyson Arkansas complex produce the product forms that the order book specifies for that day's production. Cone systems position each carcass for the automated cut sequence. Rotating blades find the joints, the hip, the knee, the shoulder, the wing, at positions calibrated to the size distribution of the day's incoming birds. Suction systems pull the breast meat from the keel in a separation that happens in under 4 seconds per bird at full line speed. The deboning machines that produce boneless skinless breast fillet, Tyson's highest volume retail product and the highest per pound value item in the cut-up sequence, operate at yield rates that the plant's quality team measures continuously. Yield is everything. A yield improvement of 0.3% across 1 million birds per day equals 3,000 additional pounds of boneless breast per day. At a wholesale price of $2.50 per pound, that is $7,500 per day. Across 250 operating days per year, it is $1.875 million annually, from a single calibration improvement on a single cut. At this scale, fractions are fortunes. The engineering investment in deboning system optimization, in blade angle calibration, in cone sizing matched to bird weight distribution, all of it is justified by yield arithmetic that compounds across millions of birds per day into financial outcomes that make the R&D cost trivial by comparison. The wing processing that runs parallel to the breast deboning line produces the product whose market position shifted most dramatically in the past 40 years. In 1980, the chicken wing was the lowest value part of the bird, destined for soup stock or further processed ground product. The buffalo wing phenomenon that began in the late 1970s in upstate New York and spread nationally through sports bar culture during the 1980s and 1990s converted the wing from a commodity byproduct into a premium menu item. Tyson's wing production, and the wing production of every major integrated poultry company, tracked this cultural shift in pricing terms that now make the wing the most volatile component of the weekly commodity chicken market. Super Bowl Sunday drives chicken wing demand to peaks that the year-round supply chain cannot fully accommodate. Tyson begins building wing inventory for Super Bowl demand in November. The production scheduling that aligns a January and February wing inventory build with the live bird supply from contract farms placed in August and September demonstrates how far forward the planning horizon of a 1-million bird per day operation extends. The further processing operations that convert fresh cut-up product into the marinated, breaded, and fully cooked items that Tyson sells under its retail and food service brands represent the highest margin tier of the Arkansas production system. A boneless breast fillet worth $2.50 per pound as a fresh commodity becomes a marinated entree worth $4.80 per pound under the Tyson brand at retail. It becomes a fully cooked grilled strip worth $7.20 per pound in a food service format. It becomes a breaded chicken sandwich patty worth $3.40 per pound as a quick service restaurant input. The further processing investment, the marinade injection lines, the breading systems, the spiral ovens for full cooking, the specialized packaging for each product form, converts commodity protein into branded, value-added products whose margin profile is categorically different from fresh commodity chicken. Tyson's further processing facilities in Arkansas and the surrounding states produce the products that appear in every major quick-service restaurant chain in the United States. McDonald's chicken. Chick-fil-A's inputs. Wendy's grilled chicken. Subway's chicken strips. These are not Tyson's branded products, they are custom formulations produced to the food service customer's specification. But they run through Tyson's production infrastructure, and the volume they represent is among the largest components of Tyson's annual revenue. A quick-service restaurant chain with 14,000 U.S. locations serving chicken sandwiches at a rate of 400 per location per day consumes 5.6 million chicken sandwich portions daily. Supplying that chain, meeting its specification for breast weight, marinade profile, cook yield, food safety documentation, and cold chain delivery, requires the production infrastructure that only Tyson, Pilgrim's, and a handful of other national-scale processors can provide. The food service supply relationship that generates that revenue is also the supply relationship that creates the most demanding quality and food safety specifications Tyson's plants must meet. A restaurant chain whose product consistency is part of its consumer promise, every chicken sandwich tasting identical in Memphis and Minneapolis and Miami, cannot tolerate the variability that commodity production allows. Tyson's further processing operations exist in significant part to eliminate that variability at the scale that keeps the restaurant chain supply chains functioning. The distribution network that moves Tyson's Arkansas production to the American consumer operates on a timeline that leaves no margin. Fresh chicken, not frozen, reaches retail within 72 hours of processing. The truck that loads at the Tyson Complex dock at 4 p.m. today will be on a Walmart shelf in Bentonville, a Kroger cooler in Memphis, or a restaurant distributor's warehouse in Dallas by tomorrow morning. The cold chain that maintains product temperature from the chill tank to the consumer's refrigerator is an unbroken sequence of refrigerated storage, refrigerated transport, refrigerated distribution center handling, and refrigerated retail display. A temperature excursion at any point in that sequence shortens shelf life, increases pathogen risk, and, if it reaches the consumer, creates the food safety and brand reputation liability that Tyson's quality assurance infrastructure exists to prevent. Electronic temperature loggers on every distribution truck. Real-time monitoring at distribution centers. Continuous temperature records that accompany every pallet from plant dock to customer receiving. The data infrastructure supporting Tyson's cold chain management generates more temperature records per day than most companies generate in a year. Tyson's corporate headquarters sits in Springdale, Arkansas, 30 miles from its processing complexes. Walmart's global headquarters sits in Bentonville, Arkansas, 30 miles from Tyson's corporate office. The proximity is not coincidence. It is the geographic expression of a supply chain partnership that shaped American food retail for 50 years. The vendor-managed inventory systems, the cross-docking logistics, the category management frameworks, all of it developed in close geographic and organizational proximity between the two companies whose combined influence on American food purchasing behavior is without parallel in the history of retail. The chicken in the average American grocery store has traveled fewer miles than the average American drives to work. 1 million birds per day. The number requires a further context to fully register. The United States produces approximately 9 billion broiler chickens per year, roughly 24.6 million per day. Tyson's Arkansas operations alone process approximately 4% of national daily production. Tyson's total U.S. operations, Arkansas, Texas, Alabama, Georgia, Virginia, and the other states where its complexes operate, account for approximately 20% of all chicken produced in the United States. 1 in 5 American chickens passes through Tyson systems. The concentration of that production in a single company is the result of 90 years of vertical integration, acquisition, and scale investment that the broiler industry's economics favor continuously. Each efficiency improvement at scale, a $50 million investment in automated deboning that improves yield by 0.4%, generates returns that justify the investment only at 1 million bird per day volumes. A 50,000 bird per day regional processor cannot make the same investment and achieve the same return. Scale begets efficiency. Efficiency finances further scale. The cycle compounds across decades into the market concentration that the American broiler industry now represents. Tyson's 4 largest competitors, Pilgrim's Pride, Sanderson Farms, Perdue, and Wayne Farms, together with Tyson control approximately 60% of U.S. broiler production. The contract growers who raise the birds, the input suppliers who provide the feed ingredients and veterinary products, and the retail and food service customers who buy the finished product all operate within a market structure shaped by this concentration. The structure John Tyson built, the contract-grower relationship, the vertical integration from genetics to retail, the branded consumer product, became the template that the entire American broiler industry follows. Pilgrim's, Purdue, Mountaire, Wayne Farms, Sanderson, all operate versions of the model that Northwest Arkansas invented and that the Tyson family scaled into the dominant form of American protein production. At 3:44 tomorrow morning, another truck will clear the same gate. 694 birds per minute will follow. The line doesn't remember yesterday. It only runs today. It ran the day before and the day before that and every operating day for decades, accumulating into the 1 million bird daily total that represents not a single dramatic production event but the ordinary operational output of a system that has been running long enough that its scale feels permanent, as fixed as the Ozark Hills it operates in, as continuous as the darkness the catching crews work in before the rest of Arkansas is awake. At 3:44 in the morning, the gate clears. The system begins again. If the scale and precision behind 1 million chickens per day, the genetics program, the contract grower network, the pre-dawn catching operations, the USDA inspection system, the chill infrastructure, the yield arithmetic, the cold chain, and the Walmart partnership that built it all in the same 30-mile corner of Arkansas, gave you a different picture of what is happening in Northwest Arkansas every single night, hit the like button and help this channel reach the viewers who want to understand how industrial food actually works at the scale that feeds a country. Subscribe for more deep dives into the systems behind everyday American food. Drop a comment and tell us where you're watching from, and tell us whether you've ever driven through Springdale on I-49 and seen the Tyson signs and wondered what was on the other side of that fence.